Hello guys, welcome back to Flowride. So today we have another experiment and it's about half-wave rectifiers. And our objective is to become familiar, to know and understand, to draw and input output waveforms. Yes. So these are the materials needed and here are the procedures. And this is the first one that we're going to make, which is figure 1. So we don't need the materials since ma'am told us that we're gonna do it in a simulation since we don't have the money to buy the oscilloscope. Obviously it's a very expensive material or tool that we cannot buy. So here we are at Tinkercad, which is this is the circuitry. I've already done it. Yes, this is the power. This is our generator, and this is our oscilloscope. One for the output, one for the input, and here is our breadboard, our diode, our resistor. And yeah, as you can see, it's simulating only 25 seconds because my laptop is very slow, as you can see, and it's working. So first thing that we're gonna do is use our BOM right here and measure. We're going to measure first the voltage of the diode, which is shown that we need to measure it. The applied voltage is 10 and the voltage of the diode, we're going to measure it with this. So negative for for the diode, the negative is at the gray line and the positive is at the red line, at the non-gray line. So we're gonna stop the simulation first. We're gonna put the positive here. Oop, wrong. There we go. Now we're gonna get the negative over here. There we go. We're gonna make that black because I'm usually seeing black as negative in the breadboards, in the wires. I don't know why. I used to think positive is black and red is negative. Okay, we shall measure. We have 475. Why is it MB? We're supposed to get. Oh, it is voltage 474, 483. Well, it's for some reason it's not constant. Keeps. Well, let's settle for 482. 482. Let's settle for 482. So we're going to settle for 482. Wait, no, I don't need this anymore. Oh, 482, and then for the voltage of our resistor, we're going to get that. Stop simulation. We're going to get the. Put it here. And put it here. So we're gonna start the simulation again. We have, it's not, we're gonna go for the highest number. Let's just go for the highest number, 476. Alright, 476 will be our for the VR. 4.76 volts. Now we're gonna watch and get our bout. Upon reading the procedure, I realized the applied voltage must have been, since it says here, measure the secondary voltage and record the measured value in the table 1. So I'm guessing that this probably is the applied voltage, which our applied voltage is, let's just go with the high number, 4.25. 5.25, I mean, so it's 5.25, 5.25 volts. But there we go, our applied voltage. Now we're gonna find our bout. So upon searching what is bout, because I haven't seen this in our discussions nor heard of it, I searched it in the internet and it doesn't apply because we only have one resistor to be exact, so we can't really measure it. So we're moving on to the total current, which is, all we have to do is voltage over resistance, if I'm correct. So we're just gonna put here NA, and then for the IT we're going to solve for the current, which is total voltage over total resistance. So we're measuring 4.76, I guess. That's our total voltage. Applied voltage is different in total voltage because there are diodes and resistance which subtract minus it from the applied voltage, and the one that is minus is our total voltage, which is 4.76. So and our total resistance is, wait, so we're gonna measure that too. Stop simulation. We're going to measure that one too. Come on. No. start the simulation. So we're gonna find out the resistance of. We're gonna find the resistance. Alright, stop simulation. We're getting an error. Start. I'm getting errors. Okay, so upon doing this, I found the resistance of our the total resistance is 4.89 ohms. So total resistance will be 4.89. That is so strange. It's in K ohm. So 4.76 volts and 4.89 is equals to let's so that would be what we get is what we get is 0.000973. Oh, that's our total current. So now that we get our unknown variables, we're going to draw the waves of the output and input. So let's check draw the waveform before and after rectification. So before, okay, before there is actually a difference from what I'm seeing. This before is higher than after. Uh, so let's imagine this is the lines. Yes, these are the lines, and there we go. This guy is at a half, and this guy is wait. There we go. Somewhere here. Yeah. This guy is higher. So now we're going to find out. We're gonna start with figure 3 first. So our work won't be, won't be scrapped. So we're just gonna reverse the diode. So we've already reversed it. Starting simulation. So okay. So we're getting almost the same with but for some reason this is higher, and we're just gonna go with 4.76. It keeps going down with that. So now we're gonna find what we're gonna find out is gonna find out. Have no voltage. So now we're going to measure the total voltage of this thing, and then the total resistance. So start. There is none. This time we're testing with a polarized rectifier capacitor. Still 5.25 negative. I guess I'm gonna start assuming it's the same since the capacitor won't hit the rest, just won't hit this front because current is going through like this. So I'm gonna assume there is still 0 volts. The voltage of the diode is still the same from number 1 to number 2. This is the part where everything is aligned perfectly and there's no negative, no reverse. This is forward bias. This is the forward bias versions. And the thing that caught me in the capacitor part, the BR, is that it's higher now because of the capacitor. 6.78. Yep, that's our last. Actually, I just checked again, and the diode is affected for some reason. When I checked again, the diode is affected now. So now we're at 1.86. The waves of this thing is pretty interesting since the shape is unusual.